not greater than 3? No. Thereby, you say print Raj. So Raj gets printed. Okay. Next, you're saying function of I plus 1. So this guy calls a function with I plus 1. I was 1 over here. I gets incremented by 1 and calls the function by 2 and n is still 3. And over here you write the same line of code I greater than n because it's the same function which is being called. So in memory it's the same one, print Raj, and then f of I plus 1 comma n. Okay, this time let's understand if this base case is executed. I is 2, n is 3, so this will not be executed. Print Raj, again you print Raj, right? Remember this function of 1 of 3 called this f of 2 3. So in recursion tree it will be f of 2 comma 3. This is how you create the recursion tree. Now f of 2 3, this is printed, and now this portion. So this guy goes and again calls f of I plus 1, so 3 comma 3, and again you write the same lines is I greater than n, then you say return. Definitely this is false, so thereby you again go and say print Raj, and you say f of I plus 1 comma n. So this is false, so this gets executed, so Raj is again printed. F of I plus 1, so this time f, like f of 2 3 called f of 3 3. So I can just draw that f of 2 3 called f of 3 3. Now f of 3 f of 3 3 calls I plus 1, which is f of 4 comma 3. And this moment I can say if I greater than n, then return becomes true. Why? Because I is 4, n is 3, and this guy comes out to be true. Thereby you're returning. So the moment you're returning, these lines will be of no use anymore. These lines will be of no use anymore. So you return. Now this is done. Now remember f of 3 3 called f of 4 3. So you can do it in the recursion tree as well. F of 3 3 called f of 4 3. Okay. So this is done. This is over. So I can say this function is over. Thereby you can return. This is done. So this function is over. Thereby this is over. You can return. Thereby this is over. You can definitely return back to where it was called. And now the program terminates. So this is how easily the recursion did work, and we did it in the parameters and not using any global variables. So I was able to print my name n number of times. Yes, I was able to print my name n number of times, and at f of 4 3 I returned. So this got completed, this returned, so this got completed, this returned. So during the course, this guy printed one Raj, this guy printed one Raj, this guy printed one Raj, and this guy hit the base condition and returned. So this is how you can easily do the first problem, which is print the name n times using recursion. Right? I hope you have understood this. So if I talk about the time complexity, space complexity, it's very, very simple. I can say the time complexity to be big O of n, because inside the functions, yes, inside the functions, these lines are like big O of 1, like they don't take any time. So apparently you're calling one function, that guy calls one more function, that guy calls one more function. So you're calling n functions. If you carefully observe, 1 2 3 4, so you're calling n functions, like near about n functions. So I can say the time complexity to be big O of n. Yes, I can say the time complexity to be big O of n. And what is the stack space? So in space complexity, we generically assume the stack space. Now this guy would have been in the stack when you called. F of 1 comma 3 would have been in the stack, then f of 2 comma 3 would have been in the stack, then f of 3 comma 3 would have been in the stack. So they were waiting in the stack till this base case return. They were waiting to be completed. So thereby I can say the space complexity is also big O of n. Now this space complexity is hypothetical, like you're not using an array. Internal, the computer's internal memory uses the stack space. So thereby making the time complexity and the space complexity to be big O of n and big O of n. I hope that makes sense. So guys, we have done the first problem, which is print the name n times or 5 times. Okay. Now let's do the next problem, which is print linearly from 1 to n. So basically, if n is given as 4, I want you to print 1, 2, 3, 4. Yeah, this is what I want as the output. Okay, so how will you do this? Again, very much similar to the previous problem. If I write down the function, it's going to be I comma n, and it's going to be I greater than n, and you're saying return, and this time the print statement will be executing I, and then you can call f of I plus 1 n is a similar one. Just in place of the name you can print I, right? So that in the main, yes, so that in the main, when you call the function, like you can take the input of n, you can take the input of n, and then when you call the function with 1 comma n, first time prints I, which is 1. Next time goes I plus 1, so 2. Similarly, you can just go on printing till whatever your n is. So it was quite similar to the previous this one where I'm easily able to print 1 to n, correct? Now it's a time to think it in the reverse order and do the next problem, which is print in the opposite fashion. Print in terms of n to 1. So, like if I give you n equal to 4, you're going to print me 4, 3, 2, 1. Now, can you do this? Can you do this? I think you can. Yes, you can. It's very simple. As of now, the code that we wrote started from I equal to 1, and then you did I plus 1, then you did again I plus 1, and you kept on calling. So if I have to print from 4, I can understand that the first I has to be 4 and the last has to be 1. After 1, before 1 you don't print. So I can say I'll just write the function, and the opposite order. It's going to be same I comma n, but this time it's going to be if I becomes lesser than 1, then I don't need to print, and I can print the I, and this time I can call it I minus 1 comma n. And during the start, yes, I repeat, during the start of main, I can take the input of n, definitely. I can take the input of n, and I can say f of n comma n to be called. Yes, I can say f of n comma n to be called. So that if assume n is given as 4, the first time, or assume the n is given as 3 to have a better understanding. The first time you call it 3 comma 3, and this calls it like 3 comma 3, correct? This line doesn't executes, print 3. So the output screen will definitely have something like 3, and then you call it as f of 2 comma 3, and again then you will call it as f of 1 comma 3, and again at the end you'll call it f of 0 comma 3, and this 0 comma 3 will be executed, and you'll come back, you'll come back, and you'll come back. So automatically you print 3, 2, 1, as simple as that. So it's the main stuff is you just change it over here where you say I'm going to do I minus 1. This is the main stuff where you change, where you say I'm going to do I minus 1, correct? So again, we have also done the next problem, which is print in terms of n is to 1. So 3 problems have been done. Now these were very basic. I want you to change it and think it in the reverse order. What if I want to print from 1 to n, but I don't want to do I plus 1. Instead, I say that the recursion call starts from n comma n usually. Like to give a better brief, let me just explain. I'm saying print from 1 to n, print from 1 to n, but I am not going to allow you to use plus 1. Like generally from 1 to n was meaning f of I plus 1 comma n was the function call, was the recursive function call that you are making. I'm not allowing you to do that. I'm not allowing you to do plus 1. So how will you do this? So over here I'm going to teach you something as backtracking. Okay, so let's understand backtracking. Since I'm not allowing you to use plus, you have to use minus. So what I'll do is I comma n, okay, as usual. This time it will be like if I at any time goes lesser than 1, you return f of I minus 1 comma n, and right after that I'm writing print of I. Okay, so over here I'm writing the main function. Over here I'm writing the main function, and what I'm writing is, okay, main, let's take the input of n, and let's call f of n comma n. So basically what I did was I said that you cannot use this plus, thereby you can use minus 1. Why? Because I wanted me to teach you what if I write the print line after the recursion call. What happens? Let's understand. So again, let's quickly give the output screen and assume n is given as 3. So the first call is 3 comma 3. Thereby the first call goes as 3 comma 3. The first call goes as 3 comma 3. Now let's understand this. Does this line execute I lesser than 1? No, because I is 3 and it doesn't execute. Perfect. Next, I'm saying f of I minus 1. So this function call will go. Remember this. The print line will not be executed. The function call will go. Perfect. Let's call the function call, and I'm saying I minus 1. That's 2 comma 3. And again, let's write if I is lesser than 1, then return. and let's write f of I minus 1 comma n, and then let's write the print of I, and then this. Okay, so let's see if the first line executes. Again no, because I is 2. Doesn't. This time again you call the function with I minus 1, which is 2 minus 1 1 1 comma 3, and this time you write if I is lesser than 1, you return, and you say f of I minus 1 comma n, print of I. Okay, let's see what happens this time. F of 1 comma 3, I is 1, doesn't executes. F of I minus 1 goes and calls this with f of I minus 1 means 0 comma 3. If I lesser than 1, return. I'm not writing the remaining couple of lines. I is 0, so this line this time is indeed true, is indeed true. And if this line is true, what happens? You basically say return executes, so you return. So this function line has been executed, correct? Now the print comes over here because after this, the line of execution comes over here and it says print I. What's the value of I? 1. So the output will be 1. Next, the execution line comes over here, which means the function has been executed, correct? Go back, went back. This line has been executed. Thereby the function line comes to the next. This print is I. What's the value of I? 2. Printed. Next, the line of execution goes here, which means this function has been executed. Go back. This has been executed. Go to the next. Print I. I's value is 3. Thereby this line has been executed. Go here. Hence go back. So even by starting from 3, I was able to output in the linearly increasing order. So it's not necessary that you have to start from 1 in order to print from 1, 2, 3. You can start from the back and you can do the task after the function call. So basically, by doing this, what you did was you made it mandatory that this line, this print print line is executed at the first, because you kept it after the function call. You kept it after the function call. So unless and until this function call is over, this line would have never been executed. So you made sure the last guy has been executed first. Why? How did you make sure that the last guy, because this was the last guy, has been executed first? How was this function completed first? By making sure the print line is after the function call, because this will only be executed if the base case is true. Thereby this gets executed, this then this gets executed, then this. That's the opposite way you made it, by writing after the function. Got it? So this is how you print from 1 is to n. Now I will be asking you to do the other one. So this is what I've done, but by backtrack, this has been done. I want you to do the other way. I want you to print from n to n. Basically, if I give you as n equal to 3, I want you to print 3 to 1, but I don't want you to use this I minus 1 comma n. I don't want you to use this. Okay, so I will not solve this. I want you people to answer in the comment section about this. Let's see if you have understood the entire concept. You should be able to do it. Yes, you should be able to do it. So remember, if I write this as a recursion tree, it's very simple. You started with f of 3 comma 3, then you went to f of 2 comma 3, then you went to f of 1 comma 3, then you went to f of 0 comma 3, which indirectly stated I'm over. Then the print line executed of 1. Then you said, after this the print of 2 was executed, and right at, so this the print of 3 was executed. So this is how the recursion tree will look like for this particular stuff. So I hope guys you have understood all the problems, and you have understood the recursion in depth for the basic kind of problems of 1D recursion. So just in case you did, please make sure you like this video, and if you're new to this channel, please do consider. So before starting this video, I'd love to thank the sponsor of this video, which is Code Studio. Now, if you are willing to practice interview problems, topic wise, this is the place where you should look for, because Code Studio has over 2000 plus problems and has all the problem solution in C++, Java, as well as Python. If you're looking for a guided path, then you can find for Python, for DBMS, for object oriented programming, operating system, computer networks, system design, web development, any other thing that you're looking for, you'll find guided paths for every other thing over here. Also, if you're looking for any top company questions, let's say if you have an interview at Amazon, if you're looking for Amazon questions, you can get all the top Amazon coding questions via tag, and all the solutions in C++, Java, as well as Python. Also, if you have an interview schedule, you can read their interview experiences, where there are 600 plus interview experiences from companies like Amazon, Microsoft, Adobe, Google, etc. So what are you waiting for? Code Studio has a lot of free resources for interview preparation. The link will be in the description. Make sure you check it out. Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. Today we will be solving a very interesting problem in recursion, which is the summation of the first n numbers. Now this can be done using a very simple for loop, but I want you to do this using recursion, because that will create your base of recursion very strong. I'm going to teach you a couple of ways. The first way being the parameter wise ways, where I'll be showing you how to do this using parameter. The next one will be functional way, where the function itself returns the answer. Okay, so to start off with, I hope you have understood the question. Sum of first n numbers. Assume n is given as 3, then the summation will be definitely 6, because 1 plus 2 plus 3 is equal to 6. The sum of the first 3 numbers is what the question states. So to start off with, let's Let's learn the parameterized way. Now, when I say parameterized way, what does that mean? That means assume I write a function. Yes, assume I write a function, and I say I, and I carry a variable sum. Okay, and that's the recursive function that I'm writing. And I say that, okay, I'm going to think this as a loop. So in the previous lecture, we saw that we started from 1, we went on to 2, we went on to 3. So we're going to do this till we don't reach n, or probably we can do it the opposite way from n to 1. So let's assume we do it from n to 1. So we can say if at any moment I is lesser than 1, yes, if at any moment I is lesser than 1, I can definitely print, yes, I can definitely say let's print the summation, okay, and then try a return. Make sense? And apart from this, what I'm going to say is, okay, f of I minus 1 sum plus I is what I'm going to pass. So this is what my recursive statement will be. And the main will be very simple again. The main will be taking an n as the input, and then we can just call f of n comma initial summation as 0. Now this is what I have taken. Now for an example, let's assume this is the output screen, and let's assume n is given as 3. So what I'm calling for the first time is I'm saying I to be 3, sum to be 0. Right? That is what I'm saying. I to be 3 and sum to be 0. This line is not executed. This line is executed, and it thereby calls another function in the same, like the same function is called in the memory, and it passes I minus 1, which is 2, because I was 3, so it tends down to 3 minus 1, which is 2, and sum plus I. Sum was 0. If you see, sum was 0, so 0 plus 3 will become 3, so it goes as 3. Again, is the if line executed? No, the if line is not executed. So the functional line will be executed, and that's I minus 1, which means something. And then sum was 3 plus I, this time is 2. Now this time this function again calls a function which says function I minus 1. So I was 2. It becomes 1, and the summation 3 plus 2 becomes 5. Is the if statement executed? No, because the if statement, if you carefully observe, it's I great lesser than 1, and that's not the case. so it's not executed. Correct? I minus conditional call, then some calls it as I less than 1. Is that the case? Was 6. So on the output, so there so we comma add with 0 the other way we print the thing. It's time functional. Don't you write a functional. This is how you can do it using parameterized. Okay. Now, if you've understood the parameterized, it's time to understand the functional. How do you generically write the functional? Because Again, is the if line executed? No, the if line is not executed. So the functional line will be executed, and that's I minus 1, which is the 1 statement is 3. When do I increment this, and it came back, and went back. Right? This is how you can do it using parameterized. Okay. Now, if you've understood the parameterized, it's time to understand the but I'm just I ended we went on to f comma 0, added this one. So whenever we ended up at 0, we just printed this because we were adding the I every time to the parameter, and that is what we printed. This could have been done in the other way where you could have done I plus 1 as well, but I'm just teaching you the parameter way in how can you actually carry the parameters. Yes, because over here we increase the parameters, and at the end of the day we came here and print this particular parameter, which is 6. So this is how the recursion tree will be, and at the end it came back, and went back. Right? This is how you can do it using parameterized. Okay. Now, if you've understood the parameterized, it's time to understand the functional. How do you generically write the functional? Because functional means you don't want the parameter to do the work. You write a recursive function where you say that, hey, listen, this is my value of n, take n as 3 and give me the summation as 6. So if I'm asking you to write such a function, that's when you cannot use parameterize, because you want the function to return the answer. You don't want it to print. You want it to return. Why? There will be a lot of cases when you learn dynamic programming that you want the function to give you back something instead of printing, right? So basically, to understand the concept before writing the recursive code, so these are all patterns that I'm teaching. It's not that I'm just writing the codes. These are patterns I'm teaching. You have to learn these patterns. If parameters are there, then you have to do it in such a way. If there's return, then you have to do it in such a way. You have to learn these patterns. Once you're very confident about these patterns, you can solve any problem in recursion. That is my word. Okay, to go with functional. Now let's understand when I say functional, what does that mean? Now, if n is given as 3 for a reason, if n is given as 3, can I say this? I can say I'll do a 3 and I'll do f of 2, where I know f of n means functional. Now let's understand when I say functional, what does that mean? Now, if n is given as 3 for a reason, if n is given as 3, can I say this? I can say I'll do a 3 and I'll do f of 2, where I know f of n means summation of first n numbers. Okay, I know this. So if I write 3 plus f of 2, makes sense? Then when I'm calling for f of 2, can I say, okay, that can be written as 2 plus f of 1. And when I'm at f of 1, can I write this as 1 plus f of 0? And everyone knows that f of 0 is nothing but 0. So I can think it in such a way that, okay, whenever there is an f of n, I know n will be there. Which is 3, because if I'm saying f of 3, I know the summation will contain 3, but I need the summation of the rest of the two numbers. So this is the idea that I'm going to follow. So what I'll say is, okay, let them give me the n. If at any moment n is equal to 0, I'm going to return a 0, because if n is 0, I know the summation of the first 0 numbers is 0. Or else I'm going to return simply n plus f of n minus 1. Okay, I'm going to simply return n plus f of n minus 1. Done. Now question might arise, how will this work? Let's understand. Let's write the main function again. So if I write main and I say n is given as 3 and I call f of 3, or f of n rather, and I write print this f of n. So what is being done? This f of n goes and calls this. So let's call this. With what value? With the value 3. F of 3 is called. Is this line executed? No. N means 3 plus f of n minus 1 is called, remember this, there's a line, incompleted line, 3 plus something, incompleted. That incompleted will be called in recursion till it does not comes. I'm waiting 3 plus something, something I'm waiting. Got that? So f of 2 now goes. It states if n is equal to 0. It says no. Now goes. I'm gonna. I know n will get f of f. So I know, say I'll do a 3 and I'll do f of 2. Where I know f of n means summation of first n numbers. Okay, I know this. So if I write 3 plus f of 2 makes sense. Then when I'm calling for f of 2, can I say, okay, that can be written as 2 plus f of 1. And when I'm at f of 1, can I write this as 1 plus f of 0? And everyone knows that f of 0 is nothing but 0. So I can think it in such a way that, okay, whenever there is an f of n, I know n will be there. I know n will be there, which is 3, because if I'm saying f of 3, I know the summation will contain 3, but I need the summation of the rest of the two numbers. So this is the idea that I'm going to follow. So what I'll say is, okay, this is the makes sense numbers. Okay, I know this. So if I write 3 plus f of 2 makes sense, then when I'm calling for f of 2, can I say, okay, that can be written as 2 plus f of 1. And when I'm at f of 1, can I write this as 1 plus f of 0? And everyone knows that f of 0 is nothing but 0. So I can think it in such a way that, okay, whenever there is an f of n, I know n will be there. I know n will be there, which is 3, because if I'm saying f of 3, I know the summation will contain 3, but I need the summation of the rest of the two numbers. So this is the idea that I'm going to follow. So what I'll say is, okay, let them give me the n. If at any moment n is equal to 0, I'm going to return a 0, because if n is 0, I know the summation of the first 0 numbers is 0. Or else I'm going to return simply n plus f of n minus 1. Okay, I'm going to simply return n plus f of n minus 1. Done. Now question might arise, how will this work? Let's understand. Let's write the main function again. So if I write main and I say n is given as 3 and I call f of 3 or f of n rather, and I write print this f of n. So what is being done? Of n minus moment n, let them give me the n. If at any moment n is equal to 0, I'm going to return a 0, because if n is 0, I know the summation of the first 0 numbers is 0. Or else I'm going to return simply n plus f of n minus 1. Okay, I'm going to simply return n plus f of n minus 1. Done. Now question might arise, how will this work? Let's understand. Let's write the main function again. So if I write main and I say n is given as 3 and I call f of 3 or f of n rather, and I write print this f of n. So what is being done? This f of n goes and calls this. So let's call this. With what value? With the value 3. F of 3 is called. Is this line executed? No. N means 3 plus f of n minus 1 is called. Remember this. There's a line, incompleted line. 3 plus something, incompleted. That incompleted will be called in recursion till it does not comes. I'm waiting 3 plus something, something. I'm waiting. Got that? So f of 2 now goes. It states if n is equal to 0. It says no. So I'm like, okay, return 2 plus f of 1. This time 2 plus, this line waits for f of 1 to be done. So I go and call f of 1. So f of 2 now goes. It states if n is equal to 0. It says no. So I'm like, okay, return 2 plus f of 1. This time, 2 plus this line waits for f of 1 to be done. So I go and call f of 1. If n is equal to 0, again I say no. Remember this, you could have written n equal to 1. That's your choice. Again, this line waits for f of 1 to be done. So I go and call f of 1. If n is equal to 0, again I say no. Remember this, you could have written n equal to 1. That's your choice. You can write it. I'm just teaching you, for f of 1 to be done. So I go and call f of 1. If n is equal to 0, again I say no. Remember this, you could have written n equal to 1. That's your choice. You can write it. I'm just teaching you patterns. That's it. Return 0. Doesn't works. Return 1 plus f of 0. Again this line awaits. I am awaiting. Let him come back. So let's go. F of 0. When you go for f of 0, let's understand what happens. If n equal to 0, returns a 0. This guy comes in with a value 0, returns a 0. This time I'm returning something, I'm giving back something. So it's returning a 0. I hope that makes sense. So whenever this function is called, it came back with 0, So can I say, now instead of writing this f of 0, I can actually write this 0 because this function yielded you a value 0. So thereby 1 plus 0 is 1. Hence return, this guy returns a 1. 1 plus 0 returns a 1. So can I say now instead of writing f of 1, can I write 1 because 1 has been returned. Thereby 2 plus 1. Can I say this guy returns a 3? Indeed I can say. Thereby f of n minus 1 goes away and I can write 3. So thereby 3 plus 3 is 6. Thereby this guy returns 6 and you say print. So output is 6. This is how, yes, this is how you can write a 6 returns and I can returns 1 has been returned. So now instead of writing f of 1, can I write 1? This guy returns a 3. Indeed I can. can say that f of n minus 1. Can I say this guy returns a 3? Indeed, I can say. The f of n minus 1 goes away. Functional stuff where the problem is broken down into smaller parts. Yes, the problem gets broken down into smaller parts, and once it is broken down, it easily gives you the output. So coming across to the code's very simple. You say int sum, you can call int n, right? And you can simply write if n is equal to 0, please return a 0, else return an n plus sum of n minus 1. And over here probably I can just keep n equal to 3. You can take this as input as well. See out sum of n. So if I just write it, you'll see this perfectly works. I saw it perfectly work. It's a very simple one. Okay, so I hope you have understood how to get the sum of first n numbers. Now if I give you a very simple task is factorial of n. What is factorial of n? Whenever I give you n equal to 3, it is 6. Whenever I give you n equal to 4, it's 24. Basically 1 into 2 into 3. This time it's 1 into 2 into 3 into 4. Correct? Multiplication instead of addition. Multiplication instead of addition. So how will you do this? I think that's very simple this time. Very simple. Uh, if I write the code, so I'll leave the parameterized, you can do it yourself. I'll try to write the recursive code. Okay. Now, you know one thing for sure, in the recursive code, this will become a factorial, correct? And this will become into, because 5 into 4 into 3, and this will become n minus 1. But we need to understand, will the base case change? Will it be n equal to 0 this time? Let's see. If I write this and if I run this, what happens? Let's understand. If I just give it a run, see, okay, sorry. Let's give it a run. So if let's change it, factorial. Okay, now let's give it a run. So if I give it a run, you see the output being 0. So you see the output being 0. Why? Due to this base case. Let's understand why did this base case give you 0? So if I write f of n and I write the base case as n equal to 0 and I say return 0 and I'm saying return n into factorial of n minus 1. If this is the code and I am writing the main function as n is given as 3 and I'm saying print f of n. So basically this guy goes and calls this with 3 not executed, 3 into f of 2 not executed. If line is not executed, so return 2 into f of 2 minus 1, which is 1. So this is gone, f of 1. Again you're writing n equal to 0, not executed. Return 1 into f of 0. F of 0 is going, and this time the if is executed and you return a 0. And you return a 0, which is absolutely wrong. Because the moment you return a 0, this guy returns a 0. And if I just strike it off, instead of f of 0, you end up writing a 0, which means 1 into 0 is 0. You get a 0. Thereby, this is striked off 0. 2 into 0 is 0. 0. This gets 0. 3 into 0 is 0. You get a 3. So what should you have returned? Yes, you should have returned ideally 1 or you should have done this. This is also correct. Or even if you keep this is also correct. You should return 1 because in case of multiplications, if you're returning 0, the overall product gets multiplied to 0, thereby giving you a wrong answer. So this is what I wanted to explain you. Again, what about the time complexity? You're basically doing 1 call, 2 call, 3 call till n calls. So I can say big of n is the time and the space complexity is an auxiliary play by giving you all three. This time and space complexity will be y big of n as the uh, is the time, and the space complexity is an auxiliary space, stack space, because this awaits, then this awaits, so there will be big O of n, uh, n functions will be awaiting to be completed, so stack space will be taken. So in stack, this is what the time. Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be again doing one more, I think couple of more problems on recursion. The first one being, we will be learning how to reverse an array using recursion, definitely. And after that we will be learning how to check if a given string is palindrome or not using recursion. Now